Orbital speed is how fast or how slow an object orbits around a central object. Now, the mass that we're using here is the mass of the central object. It's not the mass of the orbiting object. And your r that you are going to use is literally the distance from the center of your central object out to the edge of your orbiting object. I'll show this in a diagram later. Orbital period is going to be how long, so you're looking for a time interval, how long it takes to get around the central object. It's how long it takes for the orbit to take place. Again, your mass is the mass of the central object, and your r, your distance, is going to be from the center of the central object out to the edge of your rotating object. Here is the sample problem that you're going to do. I'll be explaining it in the next few slides, but please make sure to read through it. The mass of Venus and the radius of Venus are located on this slide. In this diagram, I'm showing you that what we're doing is we're adding the radius of Venus, which is 6.05 times 10 to the 6th meters, and we are adding it to 3.61 times 10 to the 5th meters. That 3.61 times 10 to the 5th meters is going to be how far the edge of Magellan is from the edge of Venus. So the reason why we're adding those two things is because for the r that we're using in the equations, we want the distance from the central object, which here is Venus, out to the rotating object, which here is Magellan. So we want that full distance. We don't just want the radius of Venus anymore, and we don't want just the distance between the two. We want the whole length. That's why we add it. In order to complete the orbital speed problem, you're simply plugging in your big G, the mass of Venus, and the RT, the R total, that I showed you how to find earlier. If you plug it in correctly using the correct exponents, how I taught you earlier, and all the correct numbers, you should get 7,118.11 meters per second. In order to calculate the orbital period, it's very similar to the orbital speed, just slightly different equation. You're still using the R total from earlier, the big G, and the mass of Venus. Your answer should come out to 5,659.02 seconds. Please remember to use exponents correctly again. Here are some tricks just to remember how to do the problems. These simple little things can help you get the correct answer as opposed to the wrong one. Now complete sample problem D, number 1, on your own. You will be doing number 1 and finding the orbital period and speed for the Earth, for Jupiter, and the Earth's moon. So you will actually have 6 answers in total. Orbital period and orbital speed for each of those planets. And you are going to use the 361 kilometers that we used in the example problem I did earlier. If you have any questions, please come see me when I get back, or you can email me over the time that I am gone. Good luck!